Okay, so in this video, I'm going to cover just one example just because of how gnarly they are. An example of how to solve a 3x4 system using substitution. Um, if you have me for Algebra 2, you'll hear me say over and over again, this is the least efficient way to solve a 3x4 system. But nonetheless, we have to see it and just, there's only one way for you to understand why I discourage its use. And what's more, I mean, it's good to practice keeping organized and just the algebraic sense that you get from doing it. But other than that, this is horrifying. But anyway, if I haven't scared you enough to turn this off, let's get started just by going over the steps that we'll use. So first thing you're going to want to do is isolate a variable, always the easiest one to isolate and no fractions ever. The next thing that you're going to want to do is plug in for that variable that you just found into an unused equation. Okay, it's got to be an equation that you haven't used just yet, and solve for another variable, a second variable. You'll be left with two when you plug in for the first one. So just pick whichever one, again, that's the easiest with no fractions given. If that does happen, which usually it doesn't, but if that does happen, you may want to backtrack and see either if you made a mistake or if maybe you just want to take another route. Okay. Third step, what you would do after you found the second variable is plug in for the first and second variables the same way you did before into the last equation that you have not used yet. Right? And then you're going to simplify and combine like terms. At that point, you'll only have one variable in that entire equation after you plug in for the other two. And that's what you'll be solving for. And then you'll get an actual value for that variable. So like you'll get an actual number for that variable, in which case you can do the last step, which is to begin working backwards to find the remaining two variables. So let's put these steps into practice on an actual example. So right here, I've got a 3x4 system. And we see that there's three equations, each with four terms, hence 3x4, right? And if you look, all three of these, we see that z is probably going to be the easiest thing to isolate, to get by itself. So I'm not even going to think about it. I'm not even going to bother about the others. Z is already by itself, quote unquote. I just need to get rid of this other stuff in this first equation or any of these other two subsequent ones. But I'm going to go ahead and just work straight down the line. So I'm going to rewrite this equation to get this z by itself, which means I'm going to say minus 7y minus 2x. So that's going to give me z by itself is equal to negative 2x minus 7y minus 53. 53 was there already. Okay, so now that I've got that, what I then want to do is plug it into an unused equation, right? So plug in for that variable in an unused equation. So I haven't used the second one yet. I'm going to plug in for z that I just found into this unused equation. Okay, so now I've got negative 2x plus 3y plus, so all of this is z. So negative 2x minus 7y minus 53 equals negative 13. Okay, so now what I'm going to do, I'm going to follow my next step here. So plug in for that variable in an unused equation and solve for a second variable, right? So let's kind of simplify this and combine some like terms, and let's see what's going to be the easiest thing to quote unquote solve for. Right, so we see that we don't need these parentheses. There's nothing being distributed into them. So I'm not going to worry about them. I'm going to pretend they're not there. So I'm going to start combining like terms, and as I combine them to stay organized and to make sure I don't reuse something more than once or forget to use something, I'm going to underline them as I go. Negative 2x, negative 2x, negative 4x, plus 3y, minus 7y, negative 4y, and then negative 53 is the only constant here on this side. Okay, so all of that is set equal to negative 13. So now I'm going to go ahead and add 53 to both sides. So that's going to give me positive 40 over here. And this is where I'm at. So I see I've got a 4, 4, 40. I'm going to divide this whole thing just by negative 4. So this whole thing divided by negative 4, that gives me positive x plus y is equal to negative 10. Okay, so I can choose either x or y. I'm just going to get x by itself. So x is equal to negative y minus 10. And then I'm going to continue in my little process, plug in for the first and second variables into last unused equation. Okay, so I'm going to plug in for x right here. So I'm going to say 6 times x, so that's negative y minus 10, plus 3y plus z. I know what z is. Z is negative 2x minus 7y minus 53. All of that is equal to negative 45. So I've got 6x plus 3y plus z is equal to negative 45. Okay, now I can also substitute here for x. So that's exactly what I'm going to do. So I'm going to go ahead and distribute this and start simplifying at the same time. So negative 6y minus 60 plus 3y plus, well, and I don't even need those parentheses. So I'm just going to say minus 2 times x minus 7y minus 53 is equal to negative 45. And I substituted x, right, into what z was. Okay, so I'm going to combine some things. So negative 6, positive 3y, negative 3y, minus 60. Go ahead and distribute this. So I've already used the minus 60. I'm already just doing this. So that's going to become positive 2y, positive 20, minus 7y, minus 53. So I already used everything. Okay, so now let's start combining. So negative 3y, positive 2y. That's going to be negative 1y. So negative y, negative 8y now. Negative 60, that gives me negative 40. And negative 93 is equal to negative 45. So last thing I'm going to do, I'm going to add 93 to both sides. That's going to give me 48 over here. And then I'm going to divide by negative 8. Y is equal to negative 6. So now I have found an actual value of a variable. So what I'm going to do here is begin working backwards to find the last two. And you can see this is a little bit insane. Okay, so I'm going to plug in for y right back over here in x. So I'm going to say x is equal to negative y. So that's negative 6. So negative y, right? Negative y. And then minus 10. So that's really 6 minus 10. And x is negative 4. Okay, and then I'm going to plug in for x now, right over here. And I'm also going to plug in for y right over here. Okay, so let's go ahead and see what that looks like so that I can find z. So z is equal to negative 2 times x minus 7 times y minus 53. That gives me positive 8 plus 42 minus 53. 8, 50. 50 minus 53 is negative 3. Z equals negative 3. Okay, and now I'm just going to check my work just to prove that I got the correct answer. Okay, so I'm going to use this OG equation right here. So 2 times x plus 7 times y plus z should be equal to negative 53. So that gives me negative 8, negative 42 here and here, minus 3. This gives me negative 50. This gives me negative 53, which is in fact equal to negative 53. And I've got it. Okay. So now hopefully you have a pretty good idea as to why I discourage the use of substitution really at all. It is good in exercise just because, it's algebra. It's just brute force algebra, and it's good to be good at this. It also teaches just staying organized, right, whether with your thoughts or on your paper. But, right, if you have a choice between this and the elimination algorithm, or later on you'll learn about matrices, definitely do the latter two. If you have any questions, you know where to find me. Otherwise, shoot me an email. Goodbye.